In this video, we're going to look at SubD versus non-SubD modeling. We'll go over how they differ from each other and their respective applications. So let's begin by defining what subdivision modeling is in the first place. SubD modeling can be defined as a process in which a 3D model is created where the topology is laid out in a manner that follows a set of specific rules so that it can be subdivided at the time of render to yield a high-poly mesh. When the topology is laid out correctly, the mesh will behave in a predictable manner upon smoothing. Non-SubD modeling, on the other hand, can be defined as a process of creating a model where little to no consideration is given to the topology, depending on the use case that is. The goal here is to simply describe the forms by whatever means necessary, and the resultant mesh isn't intended to be subdivided. Now, real-time models, CAD data, decimated meshes, and scan data can all be classified as non-SubD models. However, when I talk about non-SubD, I'm talking about meshes that are generated during concept modeling, where booleans and cutting tools are spammed to quickly create highly complex models where the end goal is to sell a design. Now let's take a look at some examples so that you can get a better understanding. Alright, so this is a concept that I created in Blender, and this is a non-SubD model. So let's just take a closer look at the mesh to analyze the topology. So I'm just going to jump into edit mode, and you can immediately see that the topology that we have here is junk. This was all created using Boolean operations and spamming the cutting tools. So if we look at the bottom here as well, same thing. All these details were achieved using Boolean operations. And if you notice these faces, these are all n-gons. So I've got tons of n-gons in this mesh, tons of triangles. Now this is not going to fly in production, but as a concept this works fine, because at the end of this I'm just going to render this out and I'm going to have a 2D image. So you can see that if I go into solid mode, like all the details here were just decals. Nothing is UV'd or properly textured, and the reason for that is properly UVing takes time, and we would rely on procedural textures if we needed to do any sort of texturing for this kind of stuff. Some of these details here are all done using modifiers and deformers. Now, despite having terrible topology, everything seems to be shading quite nicely, and these are all because of shading tricks. And this technique is basically all just smoke and mirrors. Now I will go into how to actually employ this technique and how to go about modeling this way in a future video. Consider this video sort of an introduction to the topic. So now let's move on to SubD models. Now this model that we have here is a SubD model, and if we were to jump into edit mode and analyze the topology, you'll notice that we've got all quads, and this is a characteristic of SubD models. You need to ensure that you have all quads in order for it to subdivide properly, and you'll notice that this mesh has been subdivided nicely and there's no kind of shading artifacts at all, and the topology is laid out in a very nice way so that when we do subdivide, it deforms in a predictable manner. So we've got no n-gons, no triangles with this mesh, and everything has been laid out in a very particular way so that it will yield a predictable result. You'll also see that the caps here are all quads, at the bottom we have all quads, and you'll also notice that at the edges we've got these control loops. We have these edges that are sort of bunched up here together, and the reason for this is to sort of tell the software to preserve the sharpness of those edges right there. And so you'll see this in all SubD models. And that's pretty much it on SubD models. Most of you are already aware of what SubD models are. Now let's take a look at the differences between the two. SubD models have flexible resolution and your hardware determines how high you can go up in resolution. Non-SubD models, on the other hand, have fixed resolution. The former obviously has a much more denser mesh in comparison to the latter. Building SubD models are a slow and methodical process and requires a lot of forethought and planning, while non-SubD modeling allows us to create highly complex objects in a fraction of the time. SubD models take longer to render compared to non-SubD models. Finally, SubD modeling is topology dependent, while topology is of little concern in non-SubD modeling. So, as mentioned previously, SubD modeling is the preferred method that is employed in VFX and animation pipelines. Non-SubD modeling is used in the concepting phase. Those same models are then utilized during pre-visualization, and these meshes are also used as 3D references during production, as it is easier to translate concepts into the final production-ready asset this way. So that's it for this video. If you'd like to see how I create 3D concepts in Blender, you can get my premium tutorial, Prop Design Workflow in Blender, from my Gumroad store, the link to which is in the description of this video. I also have other tutorials and resources that you can check out. You can also directly support the creation of content on this channel by pledging a few dollars a month on Patreon. I have some perks that might be of interest to you. Don't forget to like, comment, and share. If you are new to the channel, consider subscribing. Thanks for watching, and I'll see you in the next one.